So now I am going to explain about the concept that is mirror symmetry. Please remember, in mirror symmetry, this is also called as equipotential method, or this is having one more name, that is pseudo connections. Okay, pseudo connections or false connections, anything you can call. So what is that pseudo connections and false connections means? Please listen, students. For example, let us consider we have a complicated circuit like this. Now let us consider we have a complicated circuit like this. We have one circuit like this, complicated circuit. Okay, we have one complicated circuit like this. I'll take it as R1, I'll take it as R3, I'll take it as R4, I'll take it as R5, and I'll take it as R6. Let us suppose the current through R1 is 1 ampere, current through R2 is 2 ampere, and current through R3 is 3 ampere. Just try to understand, students. For example, 1 minute, I will erase this, then it will be very easy. You can understand it better. Yeah, fine. Now let us suppose 1 ampere current is entering into the junction here, and 2 ampere is entering into the junction like this. Now 1 ampere current, after entering into the junction, it is passing through the R5 resistor like this. In the same way, 2 ampere current, after entering into the junction, it passes through the 4th resistor like this. Okay, so which means that the 2 ampere current, if you take the 2 ampere current, this 2 ampere current is just passing from R2 to R4 like this. So 2 ampere current is passing from R2 to R4 like this. And 1 ampere current is flowing from R1 to R5 like this. Okay, so 1 ampere current is entering and leaving like this. 2 ampere current is entering and leaving like this. Then we can say that this connection is a virtual connection or pseudo connection. Now this connection is a virtual connection or pseudo connection. So pseudo connection means there is no connection between the resistors. Okay, so that connection is called as virtual connection or pseudo connection. So how much current is entering, same current is leaving. Then in such cases, you can neglect the connection. If you neglect the connection, the circuit will be like this. Now if you neglect the connection, the circuit will be like this. So here there is false connection. Okay, so whenever, try to understand one point, whenever the same current, how much current is entering, if the same current is leaving. Now whenever how much current is entering, the same current is leaving, then we can feel the connection is a virtual connection or a pseudo connection. Okay, I'll give you one more example, just try to understand, to differentiate what is the pseudo connection as well as real connection. Now for example, I'll take it as a resistor R1, and this is the junction. I'll take it as a resistor R2, and I'll take it as a resistor R3. I'll take it as a resistor R4. Now I'll take this current as 1 ampere. I'll take this current as 2 ampere. Now listen students, Now for example, here 1 ampere current is flowing through R4 and 2 ampere current is passing through R2. Now can you tell me, this connection is a pseudo connection or a real connection?
Real connection.
Yeah, please tell me. Real connection? Huh? Yeah, how can we say? See, this 1 ampere current is passing like this. 1 minute. Okay, just 1 minute. Yeah, this 1 ampere current is passing like this, students. 1 ampere current is passing like this, and 2 ampere current is flowing like this. So obviously there is connection between R2 and R3, and similarly there is connection between R1 and R4. So that this connection is a real connection, but not a virtual connection. Did you understand this point? Whereas if you take the previous case, this is R1, and let us take this as, for example, R2, and let us take this as, for example, R3. I'll take this as R4. Now 1 ampere current is like this, 1 ampere current flowing through R2. Current is flowing through R3, 2 ampere current is flowing through R4. So here 2 ampere current is flowing like this, 1 ampere current is flowing like this, which means that this connection is a fake connection or else virtual connection. Whereas this connection is a real connection. Please remember this. If you can understand this point, then you can solve any typical problem till JE advanced level. Understood this concept? Yeah. Now I'll give you the connection. Now I'll give you the circuit. One minute. I will erase this. Yeah. So the question is, what is the effective resistance between A and B? Now, what is the effective resistance between A and B? Now, this is the circuit diagram. Okay, so this is the circuit diagram. I'll take it as A, I'll take this point as B. Understood this point, students? Now, let us suppose all the resistance are having equal resistance R only. Now, all the resistors are having equal resistance R only. Okay, so this was the question. Please try to understand this was the question. Okay, now listen. For example, if you take the current is passing from A to B. Now let us consider current is passing from A to B. So I'll take the current direction from A to B like this. Now please remember, from this junction, current will divide equally. Why current will divide equally means, please listen, why current will divide equally means, here also resistance are, here also resistance are. Therefore, current through this branch is I by 2, current through this branch is I by 2. Now just try to understand. This I by 2 current is entering into this junction. From this junction, how current will divide? Please tell me. Yeah, please tell me from that junction how current will divide. Yeah, please reply anyone. Anyone is there? I by 4 and I by 4. Because again these two resistors are same, right? So how the current will divide means this current is I by 4. This current is I by 4. Fine. You know one point, no? How much current is entering into the circuit, the same amount of current will leave the circuit. Now, can you tell me what will be the current in this direction? What will be the current in this direction?
I by 2 and I by 2.
Yeah, very good. I by 2 and I by 2. Now, from this junction, we are getting I by 2 current means this current is I by 4. Can you tell me what about this current? I by 4, right? Because I by 4 is I by 4. These two currents are entering into the junction. Then here the current coming out of the junction will be I by 2. I by 4 plus I by 4, that is I by 2. In the same way, can you tell me at this junction, I'll take it as PQ. Can you tell me at junction R? Can you tell me at junction R how the current will divide? At junction R, how current will divide?
I by 4.
Yeah, I by 4 in this direction. And in this direction, I by 4. Now here current is I by 2 means this I by 4 current will passes like this. Then can you tell me what will be the current in this branch?
I by 4.
Yeah, I by 4. So which means that in this case, This I by 4 current is flowing like this, again going like this. This I by 4 current is flowing like this, again going like this. Therefore, the connection, whatever we have, this is a pseudo connection. Understood this point now? Then how to modify this diagram means you can modify this diagram like this. So this is resistor R, this is resistor R. Now you can take this resistor as R, this resistor is R, this resistor is R, and finally this resistance is R, this resistance is R, this resistance is R, and here we have R, here we have R, and this is the connection loop. Nothing is there. We remove the connection at the center. That connection will become false connection. Understood this point now? Now, I will explain this in another way. Please remember, if upper part and lower part of the circuit are same, then you can use the folding symmetry. Okay, that is called as folding symmetry. Yeah, we can use the folding symmetry, or else that is also called as folding method, or else that is also called as 1 minute. Yeah, fine. So this is also called as folding symmetry. Okay, folding symmetry, or else you can call it as lateral method, because you fold the circuit in a line perpendicular to the AB. For example, we have to calculate the effective resistance between A and B. You have to fold along the line perpendicular to AB. Okay, that is called as lateral method also. Fine, let it be. Please remember, if upper part and lower part of the circuit is same, then just to fold the circuit. If you fold for one time, you have to divide the resistance by 2. If you divide, or if you fold for 2 times, if 2 times folding is possible, then again 1 by 2. So 1 by 2 means 1 by 2 means 1 by 4. If you are going to divide for third time, or if you are going to fold for the third time, then you can take it as 1 by 2 into 1 by 4, that is 1 by 8. Okay, for example, in this circuit, if 2 times folding is applicable, if folding is applicable 2 times, then we have to divide the resistance by R by 4. If 3 times folding is applicable, then you have to divide the resistance by R by 8, like that. Understood this point, students? Now please listen.
Yes.
I'm folding for the one time. Yeah, I'm folding for the first time. If you fold for one time, this circuit will be modified like this. This is resistor R, this is resistor R, and this is R, and this is R, and this is R, and this is the point B. This is the point B. If you fold, this resistor is going to touch this resistor, then you have to write it as R by 2, because we folded for one time. Then this resistor is going to touch this resistor, then the resistance is R by 2. This resistor is going to touch this resistor, then resistance is R by 2. This resistor is going to touch this resistor, then resistance is R by 2. This resistor is going to touch this resistor, again the resistance is how much? R by 2. Okay, students. Now tell me, what is the final calculation? What is the effective resistance between A and B? Do the final calculation, tell me. Do the final calculation and tell me. I'll give you 1 minute. Yeah, do the final calculation and tell me what is the answer. What is the answer, man? These two are in series or in parallel? Series. Then R effective is equal to R. Then this and this, these two are in parallel. Then R effective can be taken as R into R by 2 divided by R plus R by 2. That can be taken as R square by 2 divided by 3R by 2. Cancel R and 2 and 2, R and R. That is R by 3. Now R by 3, R by 2, R by 2 are in series. Calculate the effective resistance and tell me what is the answer. Yeah, tell me what is the answer. My voice is audible. Calculate my R by 3 plus R by 2 plus R by 2.
R by 7.
Yeah, how much more?
R by 7.
R by 7. So you can write like this. R by 2 plus R by 2 R plus R by 3. That is 4R by 3 is the answer. Okay, 4R by 3 is the answer. If you're done with this, I'll go for the next point. Is it done, ma? Yeah. So
Yes,
before
sir.
going to that, I will tell you the same problem in much more easy way. In much more easy way. Just try to understand, okay? Shall I?
Yes, sir.
Yes.
Now this is the circuit diagram. Same before problem only. Actually, this you can understand very easily, but one small drawback is there. You can't apply always. For that also, I will tell you one more point. Okay. Always you can't apply, because always if you apply this mirror concept, for some problems it may be difficult. So if you want to apply this mirror concept and if you want to do the problems in an easy way, I'll tell you another point, small point. That's it. I'll include one small point. That's it. Okay. Now listen. For example, in this question, between which points they're asking effective resistance, take that points perpendicular to this effective resistance points. For example, if they ask between A and B, now for example, if they ask between these two, Q and S, then perpendicular to the Q and S points. Are you clear? Or else here I'm asked between A and B, effective resistance between A and B. So perpendicular to A and B, imagine one mirror like this. Here imagine one mirror like this. Then left hand part of the circuit and right hand part of the circuit must be same in case of mirrors. Because in case of mirrors, object and image will be same, right? Image and object will never change. Opposite way. So left hand part of the circuit and right hand part of the circuit both must be same. This is the condition. If both are same, in its path, in the along the mirror, if any connections are there, remove that connections. That's it. Then need not to divide current I by 2, I by 2, I by 4, I by 4 and all. Between A and B, if you feel that left hand part of the circuit is equal to right hand part of the circuit, then you may get one doubt. Sir, why can't we keep the mirror like this? If you keep the mirror this way, then what will happen means current will never flow. Okay, so please remember, you have to keep the mirror between A and B perpendicular to A and B only always. Please remember that point. Are you clear? So if you keep a mirror perpendicular to A and B, in this mirror, okay, in this mirror, along this mirror, whatever the connections are there, remove the connections. That's it. Here along the mirror, whatever the connections are there, remove the connections. If you remove the connections, again the circuit diagram will modify like this. Did you understand this point now? Yeah. Fine. Now please remember one more point. Now based on this mirror, you just apply problem or apply mirror problem to this. One more example which I given to you. Yeah. So take this example, calculate the effective resistance and tell me what is the answer. Take time, no issues, calculate. So I asked between A and B, then you have to take mirror perpendicular to A and B. Where we have to take the mirror, identify that and calculate the effective resistance.
Sir, I'm not able to hear you properly.
Yeah, did my anyone? Is it done, ma? Anyone? Please reply.
Sir, please explain that concept once.
Yeah, fine. Now listen. Between A and B, we have to find out the effective resistance. So imagine the mirror perpendicular like this. The mirror perpendicular to the mirror like this. Now along the mirror, whatever the connection is there, neglect the connection. Okay, so this is the simple thing. Along the mirror, whatever the connections are there, remove the connections. Okay, if you remove the connections, this is the final circuit diagram. Now, if you remove the connections, this is the final circuit diagram. So you have to remove the connections, right? If you remove the connections, this is the circuit diagram. That's it. Okay. Do you understand this point or not?
Yes, sir.
Now this resistance is R, this is R, this is R, 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 and R. Now you can fold it. So fold it. So while folding, you have to fold on AB. Now while folding it, you have to fold along AB line. So if you fold along AB line, then this is the final resistance. I will draw the final resistance like this. Yeah, fine. Listen, if I fold the lower part into upper part, then please remember this resistor is going to touch this resistor. Therefore, this will become R by 2. This resistor is going to touch this. Therefore, one time we fold it, so divide by half. This resistor is going to touch this resistor. Therefore, this resistor becomes R. Touch this resistor. Therefore, it will becomes R by 2. This resistor is going to touch this resistor. Therefore, this is also becomes R by 2. And this resistance is R. This resistance is R. Because you can't fold this. Okay, with reference, with effect to this, we are folding the upper resistance. Understood this point?
Yes.
Yeah. Now you can calculate the final effective resistance. Calculate it. Yeah, calculate the final effective resistance.
Sir, it's bit confusing topic.
Which one? No, which part is confusing?
Sir, like dividing this circuit.
No, no. Actually, nothing is. This is a resistance here. Okay, if you feel confusion, then follow the regular method only. These two are in series. These two are in series like that. But why I'm telling that method means for calculation it will be simple, okay? Easy calculation. Nothing is there. You see, upper part and lower part are same, right?
Yes, sir.
So if upper part and lower part are same, if you calculate the upper part effective resistance and lower part effective resistance, then upper part effective resistance also will give one value. Lower part resistance also will give one value. Both will be same. Okay, let us suppose we got this resistance as 4 by 3R. Now we got this resistance as 4 by 3R. Now again 4 by 3R and 4 by 3 are in parallel. So if 4 by 3, 4 by 3 are in parallel, then effective resistance is again 4R by 3 by 2 because effective resistance in parallel is equal to R by N. So upper part is 1, lower part is 2. So two parts are there, right? So divided by 2. So R is how much for 4R by 3. So 3 will come to the denominator 4R by 6. So if you calculate the effective resistance for upper part and lower part, you will get 4R by 6 generally. Now please remember, now what I'm telling means, instead of calculating the upper part and lower part, so how to save the time means, how to save the time is, upper part and lower part are having same resistances, and upper part and lower part are similar to each other. Then what to do means, we can fold it. Okay, if you fold this entire lower part will going to touch the upper part. Am I right?
Yes,
Now,
sir.
how many folding? One time we folded. No, we fold one time. If you fold for one time, divide the resistance by half. If you fold for two times, divide the resistance by 4. If you divide, if you fold for three times, divide the resistance by 8. Means 2 power n type. Now, please remember, upper part and lower part are same. Please remember here, upper part and lower part are same. Both are same. Okay, if upper part and lower part are same, then what we can do means, we can fold this circuit. Okay, we can fold that circuit. Okay, if you fold the circuit, just see students, lower part, upper part, all are same. Then if you fold the circuit, this lower part is going to touch this resistor on upper side. One minute, just give me. Okay, so please remember, this lower part is going to touch the upper part. So how many times we are folding means, we are folding for one time. Therefore, if you fold for one time, resistance is taken as R. Okay, then this resistor is going to touch this resistor. Then this resistance becomes R by 2. So like that, this resistance is going to touch this resistance. This is R by 2. Like that, every resistance becomes R by 2. But this resistance will never change because we are not folding this. No, because we are not folding this. Okay, this resistance we are not folding. We are folding the lower part into upper part. You know, folding right now. If you take one paper and if you fold, both the edges will stick together, right? Okay, so which means that we are making half. That is the logic we used here. Okay, no sir, if I feel confusion, this folding and all means, you can follow the regular method only, like upper part is in series and parallel, lower part in series and parallel, and calculate. But it takes a lot of time. So instead of calculating this, we can use the folding method. Okay, now listen. These two are in series, then calculate effective resistance R. Then this R and R by 2 are in parallel, therefore 3R by 2. Now 3R by 2, R by 2, R by 2 are in series, therefore what is the total value? 5. So 5R by 3. Now 5R by 2 and R 2 are in parallel. So
Sir,
4R by
last answer
into
is
2R
4R by
divided by
5.
5R by 2. 4R by 5R. Yeah,
Yes.
please tell me. Yeah, tell me, if you do the calculation, can you tell me what is the final answer?
Sir, 4R by 5.
4R by
5.
5. Now listen, these two are in series, right? Then what is the effective resistance means, R by 2 plus R by 2 R. Then this and this are in parallel. Then effective resistance in parallel is equal to R by 2 into R divided by R by 2 plus R. That is equal to R by 3. Correct?
Yes, sir.
Then, one minute. Then instead of these, you can write it as R by 3. Now, instead of all these things, you can write it as R by 3. So R by 3, R by 2, R by 2 are in series. Then effective resistance in series is R by 2 plus R by 3 plus R by 2. That is equal to R plus R by 3. That is equal to 4R by 3. Now total upper part is 4R by 3. Lower part is 2R. Then effective resistance in parallel is equal to 4r by 3 into 2r divided by 4r by 3 plus 2r. That can be taken as 8r square by 3 divided by 3 2s are 6, and this is how much? 4. That is 10r by 3. Cancel these two. That is 8r by 10, which is equal to 4 by 5r. This is the answer. If you still feel confusion regarding these problems, I will give you one more example. Yeah, I'll give you one more example. This directly, you can apply the folding method. You can apply directly folding method for this. This is point A, this is point B. This is taken as capital, smaller, smaller. Now, effective distance between A and B. Try to calculate.
Sir, capital R into 2 small r divided by r.
Yeah, fine. So listen, I hope everyone joined.
Yes, sir.
Yeah, fine. See, if you observe the circuit, it looks like upper part and lower part are same. Then folding is.
Sir, your video is off.
Oh, sorry. I didn't share. Yeah, I hope you can see the screen now.
Yes,
Yes,
sir.
sir.
Yes.
If you observe the circuit, no, the upper part and lower part are the same, right? then you can fold this one easily. Now you can fold
Yes,
this
sir.
one easily. Now if you fold this one, this resistor is going to touch this. This resistor is going to touch this. Then you can modify the circuit like this. Now you can modify the circuit like this. This is R by 2. This is R by 2. And this resistance is smaller. And this resistance is smaller. And I'll take it as point A. I'll take it as point A. Now R by 2 and R by 2 are in series or in parallel?
Series.
So that is R. Now R and R are in series or in parallel? No? Series. Now what is, yeah, 2 are, 2 smaller. And this is point A, this is point B. Now R and 2R are in series or in parallel?
Parallel.
So what is the effective resistance means? Capital R into 2R divided by capital R plus 2 smaller. This is the answer. So 2 capital R smaller by capital R plus 2 smaller. That is R effective. Okay. Now I'll give you one more problem. Then whatever the doubts and confusions is there, just to try to avoid the confusions with this problem. Okay. After this class, I will send you the screenshots of it, or else take the screenshot of all these problems, and once you refer, you will understand it. And still, if you have doubts, you can text me. I will try to convey you in a easy way. Okay. Shall I give one more problem?
Yes, sir.
Yeah. Now listen. First, you identify whether it is a mirror or else directly we can apply the folding, or else whether we have to apply the mirror. Okay. Then, if mirror is applicable, apply mirror. If mirror is not applicable, directly fold it. Okay, no? Yeah. This time I'm giving bit complicated one. Okay. Yeah, leave it. I'll give you next problem. First, you do this. One minute. So the question is, what is the effective resistance between A and B? Now the question is, what is the effective resistance between A and B? This is also I'll explain. No, this is also I'll explain. Just try to understand this time this very clearly. Then we'll go for the other things. Now listen. Solving problems, maximum everyone will solve, but solving in a easy way, in a short way, and in a fast way. That is important. That is good thing, because we have to solve any problem within 1 minute. So you have to be fast. You have to do the calculation fast. So for that, how easily, how conveniently we can reduce the problem, that much conveniently we can reduce the problem. Okay, so please understand. So I will tell you the problem how to solve. So here we have to calculate the effective resistance between A and B, right? Try to understand clearly. We have to find out effective resistance between A and B. Now listen. If I keep the mirror here, then left hand part and right hand part are equal. Okay, now please remember. I'll keep the mirror like this. Then left hand part and right hand part are equal. Understood? Now please remember, along the mirror, whatever the connections are there, neglect the connections. Now along the mirror, whatever maybe the connections are there, neglect the connections. Okay, students. Did you understand this point?
Yes, sir.
Yes, sir.
Now, if you neglect this connection, but along the mirror, one resistor is also there now. You have to neglect that resistor also. Okay, no? So not
Yes,
only connection,
Yes, sir.
we have to neglect the resistor also. If you neglect the resistance also, this is the circuit diagram. Okay, so this is the circuit diagram. Okay, not only neglecting the resistors, sorry, connections, you have to neglect the resistance also. Okay, so this is the resultant circuit diagram. Now, please remember, I removed the connection here. So I removed the connection here. And I neglected this resistor because this resistor is along the mirror. Along the mirror, if any resistors are there or else connections are there, remove the connections, neglect the resistance. Now remove the connections and neglect the resistance. Now this is R, this is R, this is R, this is R. Okay. Now please remember, if you imagine one more resistor here, you have to neglect that resistance. If you include that resistance also, this entire part look like what? Now this entire part look like what?
Wheatstone Bridge.
That's it. Okay. Now I give you one more shortcut. In Wheatstone bridge, if all the resistors are same, what is the effective resistance?
R.
R.
Oh. So instead of this entire circuit, what we can substitute?
R.
R.
So you can draw the resultant circuit like this. See how easily I'm going to draw the circuit. This is R, this is R, and this is R over. See, the big complicated circuit we reduce in a small way. Because this middle part, this entire middle part, you can write it as R. So this entire middle part, how I'm going to write this entire middle part, I'm going to write it as R. And this resistance is R, this resistance is R. Then upper three resistors are in series or in parallel.
Series.
Series.
What is the effective resistance?
3.
Yeah. So upper three are in series. Then what is the effective resistance means? Then effective resistance is equal to 3R. And lower two resistance are also in series. Now what is the effective resistance means? 2R. Now 2R and 3R are in parallel.
2R.
Their effective resistance in parallel. Yeah, 3R into 2R divided by 3R plus 2R.
6R by 5.
Very good. 6R by 5. This is the answer. I hope you understood this point, students.
Yes, sir.
Yes, sir.
Yeah. Now here the condition is one small thing I will tell you, please remember, because now you will remember, later you may forget. If I consider this point as P, if I consider this point as Q, this P and Q are equipotential points now. Now P and Q are equipotential points. Why? Because here current will divides into two parts, right? I will take it as I by 2, I by 2. Now here current again divides into two parts, I by 4 and this is I by 4. Now what is the potential drop between these two points? Plus potential drop between these two points is V is equal to I by 4 into R. Now what is the potential drop between these two points? Is again same, V is equal to I by 4 into R. So these 2 points are equipotential points. If potentials are equal, then current will not flow, because according to Ohm's law, V is proportional to I. V is called as a potential difference, not a potential. V is called as what? Potential difference. If both are at same potential, then potential difference is equal to 0. Okay. No, sir, I'm feeling still confusion to remember all these things. Means blindly remember one point. If you take a mirror, along the mirror, if any connections are there, or else along the mirror, if any resistors are there, remove the resistors and remove the connections. That's it. This is what I can explain much more easily. Okay. So along the mirror, whatever the resistance are there, whatever the connections are there, you can neglect the connections and mirrors. Okay. Now I'll go for the next question. This time this question you have to solve. Shall I give?
Yes, sir.
Yes, sir.
Yes, sir.
So this question you have to solve. Okay. problem. So same like previous one, but I'm attaching lower also one part. Okay, same like previous problem, but this time I'm attaching lower one more circuit. That's it. Okay, what is the effective resistance between A and B? This time you should solve. Every resistance is R only. No, every resistance is R only. Okay, this time you must solve. Okay, take time, no issues, and solve it. You have to be clear about this concept by this problem.
Sir, 6R/7.
Sir, 4/5R.
Very good. How much? 4/5?
Yes, sir.
Yeah, very good. Who told them?
Sir, I Vidya.
So you have to imagine mirror like this, because this you have to identify now. This you have to get through practice. Because if you keep the mirror
Sir,
like this,
6/7 are.
equal, then what we can do, we can neglect the middle connection, which is a false or fake connection. Now, which is a false or fake connection. Okay. Now please remember that how you can modify the circuit means you can modify the circuit like this. So this is the circuit. This point is A, this point is B. Now this resistance is R, this resistance is R, this resistance is R, and this resistance is R, and this resistance is also R, this resistance is also R, and this resistance is R, this resistance is R. Okay, 1 minute. You can neglect the middle connection. Okay, you can neglect the middle connection like this. Yes. So like this. Then again, what we can do? So the upper part and lower part are similar to each other. So the upper part and lower part are similar to each other. Then what we can do? If both are similar to each other, what we can do? If upper part and lower part are similar to each other, what we can do?
We can fold them.
Yeah, we can fold. So see, if you fold this, so if you fold this, okay, then the resultant circuit diagram will be like this. Now, if you fold this, then this is the resultant circuit diagram. Yeah, 1 minute. Just 2 minutes. So if you fold this one, then this is the resultant circuit diagram. So if you fold this, then this is the resultant circuit diagram. So the resultant circuit diagram will be like this. This is resistance R, this is resistance R, and this is resistance R, and this is resistance R, and this resistance is R, and this resistance is also R. This is the resultant circuit diagram. And this resistance is R, and this resistance is also R. Now tell me, if you fold the lower part to upper part, this resistance is going to touch here. Therefore, this resistance will be R by 2. This resistance is going to touch here. Then this resistance is also how much? R by 2. In the same way, this is going to touch here. Then this resistance is R by 2. This resistance is going to touch here. Then this resistance is R by 2. This is going to touch here. Then that resistance is also R by 2. Then this is going to touch here. Then this resistance is also R by 2. Understood this point, students? Now, again, if you take the middle part, the middle part again looks like Wheatstone bridge. Then what is the effective resistance? Please tell me what is the effective resistance?
R by 2.
R by 2.
R by 2. Therefore, you can write the remaining circuit diagram like this. This point is here, this point is B. Now, these two are in series. Then effective resistance here, you can write it as 2R. And from here, this is R by 2. Now, all the 4 resistors are equal. Therefore, this resistance will be R by 2. And this resistance will be R by 2. Now, again, in the numerator, all 3 are in series. Then effective resistance is 3R by 2. And this is 2R. So, 3R by 2 and 2R are in parallel. Then effective resistance in parallel is 3R by 2 into 2R divided by 3R by 2 plus 2R. That can be taken as cancel 2 and 2, or else you can write it as 6R square by 2 divided by this value will be how much? 2 2s are 4, 4 3s are 7. So 7R by 2. Cancel these two, R and R. Then 6 by 7R is the answer. Okay, students. Okay, students.
Yes, sir.
Yeah. So if you're done with this, you may leave the class tomorrow. I'll explain 2 more problems and I will wind up this chapter. Then I will start the new chapter from Monday onwards. Okay, and Sunday you have
Okay,
examination, one more examination. Yeah, Sunday you have one more examination on this chapter. You can attend the
Okay,
examination
sir.
on Sunday. Okay,
Yes,
so
sir.
will you take the screenshot of this problems now?
Yes.
Sir, next you will start moving charges and magnetism.
Yeah, moving charges shall I start or optics?
Sir, moving charges.
Sir, optics.
Yeah, okay, fine. Anything we can do. So first take the screenshots of this problems. Or else I'll send you the PDF document, okay?
Yes, sir.
Sir, because
Okay, sir.
for us, optics theory part is over.
Yeah, theory part is over. So shall I start the problems directly?
Sir, no, if
Yeah,
you
fine.
take
Let it be.
optics, it will be easy.
Okay, fine. Let it be. I'll speak with you personally, then I'll start it. So I'll send the entire chapter in a PDF format. Then you can
Sure,
go
sir.
through the chapter once again. Tomorrow I'll explain two things. No, one is a cube network. Actually, cube network is very important. A cube network and infinite network. These are important for JEE examination point of view. For NEET, it is not at all important. These two topics we'll discuss tomorrow, and day after tomorrow I'll give you time for preparation. Sunday you write the exam. Monday I'll start the new chapter. Okay.
Okay, sir. Thank you,
Okay,
sir.
sir.
You will
Thank
do
you,
that.
sir.
Thank you, sir.
Thank you.